everyone, and welcome to Mrs. Brayho's Science Lab for this week. I've got a friend that I'd like you to meet. This is my olive python Brayho, and he's having a great afternoon crawling around my house. Say hello everybody to Draco. This week's episode is dedicated to about 4 different people who have asked me questions, and we'll get into those questions in just a little bit. But olive pythons are native to Australia. They live in the Northern Territory. They can get quite a lot bigger than this. This one, he's about 2.5 meters long. He lives in my house, he eats rats. But for the ones that live out in the wild, they can eat wallabies and crocodiles. How cool is that? See ya. Hi everyone, and this is another segment of Mrs. Brayho's Science Lab where Eli asked the question, how high does the space shuttle travel? Well, Eli, we need to have a look at the Earth and its layers of atmosphere to answer that question. So if you have the Earth here, which is the globe in which we live, and then there are 5 different layers of the atmosphere. So to make this a little bit more easy to understand, what I'm going to do is I'm going to cut the Earth out of the picture, and then I'm just going to pop this drawing here on top so that you can see it. Okay, so if you're imagining that you were in the space shuttle traveling up into space, you would have to go through all of these different layers of the Earth's atmosphere in order to get to this part here, which is called the thermosphere. The space shuttle can fly 400 kilometers up into the air, and the space station is at the edge of the exosphere and the thermosphere. Some other really interesting things that go with our atmosphere is that this area here, the mesosphere, that is where you would see all the meteorites, the shooting stars that you see of a nighttime burning up. They burn up in this layer of the atmosphere. And then we have the stratosphere. Now the stratosphere is really cool because in the stratosphere, that's where all the spy planes are. Any of our satellites are also up here in this stratosphere area. You can see this red dotted line here. That's the ozone layer. Now when we go later into the episode, we're going to talk about the ozone layer a little bit more because Ethan has asked the question, what does global warming mean? And global warming has a lot to do with this layer here called the ozone layer. Now the last layer here is the troposphere. We live in the troposphere. The top of Mount Everest doesn't even reach the top of the troposphere yet, though, but this you can see where the cloud layers are. And when we fly in a jet plane, we are flying in the troposphere. But the troposphere is only 10 kilometers above the Earth. If you have a look up all the way up here, okay, there's the space station, 400 kilometers above the Earth. And then if you wanted to get to the moon, you'd have to travel another 380,000 kilometers through the exosphere, which is space, to get to our moon. Okay, so the next question comes from Ethan, and he said he wanted to know what climate change and global warming was. Before we explain what climate change and global warming is, we have to look at the difference between weather and climate, and it's the biggest question, and it's probably one of the confusing issues of the whole big question. When you look at weather, it's what's outside your outside your window. Is it a sunny day? Is it cloudy? Is it raining? That's the weather. And it's controlled by the air currents, the seasons, and it's also controlled by where you live on the planet. If you have one cold day in summer or one hot day in winter, you can't call that global warming or climate change because that's just a change in the weather. But if you look over here, we're going to talk a bit more about what is climate. So climate is defined by how much rainfall a geographical location has, and the rainfall can often be seasonal. So for example, in Melbourne, we have lots and lots of rain in winter, but in Queensland, they have their rain in summer. It also talks about the temperature, and that's the range of temperature from where you live. So again, in Melbourne, we have really cold temperatures during the winter and medium temperatures during the summer. But somewhere like Queensland again, they have moderate temperatures during their winter and hot temperatures during their summer. And it's also controlled by the ocean currents and air currents of the geographical location. So once you know the difference between weather and climate, we can talk about what climate change and global warming is. When the Earth was formed, about 500 million years ago, we had 5 layers of atmosphere that came over the top of the rocks once they came together. Now, this is a really simple way of explaining it. And once we had those layers in place, and once the Earth was in the gravitational orbit of the Sun, things really settled into patterns and seasons, and that's where we got, again, our climate and our weather from. One of the parts of, or the interesting parts of the Earth in particular, is that we have a layer above the Earth's atmosphere, or it's actually above this troposphere, and it's in the stratosphere, called the ozone layer. Now, when there was just plants and animals on the planet, the trees produced the oxygen, and all other life forms, we produced as a byproduct carbon dioxide. So you had a balance. The ozone layer, when there was just that balance on the planet, allowed for some of the heat that was produced by the Earth to escape back out into space. But the ozone layer, more importantly, allowed for heat to come through, but it also reflected a lot of the heat back out into space. So we got a measured amount that came down to Earth. Now, what happened was that over time, we got things like farms, okay, and we got industry, okay, and we got lots and lots of people living on the planet, lots of people who lived in lots of houses, okay, and because of all of these things happening, we also cut down a lot of our trees. Okay, so we cut down the trees, which then unevened the balance of oxygen. And because then we had all of these things, this is what we had ourselves producing carbon dioxide, what it did was the unbalance allowed this ozone layer then became like a thick blanket. And because the ozone layer is now a thick blanket, it's trapping all the carbon dioxide in closer to the Earth, and it can't get out into outer space. And so over time, which we've seen over particularly the last 150 to 200 years, this blanket of carbon dioxide has made the climate in different parts of the world change. So we've had climate change, which is a sustained and measured change in the sea and the land temperatures, which has led to the ice caps melting, the sea levels rising, droughts and extreme weather conditions that are happening on a more regular basis. Because what the Earth is trying to do, the Earth is trying to balance it all back up again. It's trying to get rid of the carbon dioxide, and it's trying to make sure that those balances come back into order. Unfortunately, humans are having so much of an impact that the Earth just can't cope and can't keep up with those changes. And that is a really simple explanation of what climate change is. Hi everyone, and welcome to another segment of Mrs. Brayho's Science Lab. And in this segment, Monty asked the question, how do bubbles get inside soft drink? When you buy a bottle of soft drink from the shelf or from the shop, the bubbles you can see are around the top, but you can't actually see the bubbles from the bottom. And that's because when you buy the soft drink from the shop, it's sealed really tightly with an airtight seal. So there's no reactions going on inside. And really, the bubbles inside a soft drink can or bottle are just simply a chemical reaction. let's see what happens when I open the bottle. Okay, you can see that you can see more bubbles forming at the top, and if we look carefully, I can see lots of fizzy bubbles inside my soft drink. Alright, so let's have a go at seeing if we can make that chemical reaction for ourselves. Soft drink really only has three main ingredients: water, sugar, and an alkaline and an acid in it to make the carbonated bubbles. So let's start off with some water. Alright. Okay, and the next thing we're going to do is we're going to mix in our bicarb. Now, the bicarb is what contains the carbon, and it's the carbon that cracks open. It's those carbon bubbles that you see when the acid is added that makes the bubbles inside the soft drink. So we're going to add some bicarb. Okay, give it a bit of a stir. Okay. Now there's nothing much happening at the moment because actually what we've made is an alkaline base. Again, this is a really simplified explanation, but it worked and it's done on a bigger scale. Okay, so the next thing we're going to do is we need a reaction. We need something to react with the carbon that's in here. This is the alkaline and this is the acid. Now citric acid is just dried lemon juice. 1 teaspoon of citric acid equals the amount of lemon juice in 1 lemon. So we're gonna increase that a little bit and we're gonna pour it in. Okay, can you see the bubbles happening in there? Okay, so essentially, if I give it a bit of a stir, and if I add a little bit more water, okay, now pour it into my jar. Okay, I've essentially made myself a soft drink. So remember, this one wouldn't be very nice to drink, and I wouldn't recommend any of you tasting it at